All right, this is the beginning of the first mountain in algebra. This is lesson 3.1. Okay, graphing linear equations. Sounds ugly, right? Graphing linear equations. Like, oh man, three big words. I will show you the basic gist here of this. Okay, everybody on the middle of page 153, I want you to read with me the highlighted section there where it says linear equations and intercepts. Are you with me? I want you to read with me here. A linear equation is an equation that forms a line when it's graphed. Okay, that's real simple. And you did do this last year in pre-algebra. A linear equation forms a line. That's what a linear equation is. Linear equations are often written in the form, this is very important, ax plus by equals c. This is called the standard form of a linear equation. This is the standard form. You will need to know this by heart. Ax plus by equals c is standard form. You should write this down right now. That's standard form. You will need to know that. Okay? In this equation, the c is called the constant, or a number. Ax and by are variable terms. Now, here's the deal. We'll come back to that in a second, but you do need to know this. Write that down somewhere because that's important. Okay. Here's the deal. Linear equations can be written in standard form. If they cannot be written in standard form, then they are not a linear. Then it is not a linear equation. In other words, then it is not a line. Here's what I mean. It needs to be able to be written ax plus by equals c, or it's not a line. For example, if I have this y equals 4 minus 3x, I need you to look at this. Can this be written in standard form? What I mean by that is this. Can I shift things around legally? Can I take things away and add things and multiply and divide? Can I do things to the balance legally to make it sit in standard form? Well, let's try. First of all, is this in standard form right now? No, not at all. Okay? Because I have an x and the y are not on the same side, right? And so there should be a single number on the right and an a and an x and a y on the other side, right? So let's check it out. What if I did this? What if I went plus 3x and plus 3x? What's that give me now over here? What's it give me? 3x plus y equals 4. Does that make sense? Is that written in standard form? Is there an x plus a y equals a number? Right? Do you see what I'm saying by that? An x plus a y equals a number. Was I able to write this out in that way? Is this an x plus a y equals a number? Yes. Therefore, this is written in standard form, which tells you that this, in fact, is a linear equation because it makes a line. Does that make sense? Okay. I'm going to put this back up here. Ax plus by equals c. I'm going to leave that there for you to see. I'm going to give you another question, and you tell me this. 6x plus, minus xy equals 4. Here's the deal. Ready? Line down the equal sign. Is this currently written in x plus y equals 4? No, this is an xy, right? It needs to be an x plus a y equals a number. This is an x plus an xy. So then could I somehow get those out of there? Could I somehow fix this? Here's what you'd have to do to get this to do it right. You'd have to go, okay, I'm going to pull out an x here, right? Then I'm going to factor out an x times 6 minus y equals 4. That works. But now this is not a single term, right? That's not a single term. It needs to be an x, 5x, negative 4x, an x plus a y equals a number. If it can't be written like that, then that is not a line. Can this be written as in standard form? The answer is no, it cannot. It cannot. Therefore, this is not a line. Okay? This is not a line. Not a linear equation. We will practice this lots. What about this? There's some other rules here. Are you ready? The x cannot be a denominator. Okay? The x cannot be a denominator, and the y can't be a denominator. You can't have this. You can't have, y over x plus 7 equals 4. This does not work because the x is a denominator. Does that make sense? That right there tells you it's not going to be a line. Also, any of the variables, if I have 2x plus 3y equals 9, first of all, you tell me, is that a line? Is that a linear equation? Yes, an x plus a y equals a number. Absolutely. What if I did this, 2x squared? A variable cannot be squared. If it is, it's not a line. Okay? I'm telling you now, the x or the y cannot be squared and still be a line. It will not be. This will be very much a curve of some sort. On the graph, it would look something like, or something like that. It would not be a line. A line being straight. Right? A line is straight. You know this, correct? Okay. So what about this? This is a good one. Okay. Is this a linear equation? Is that a line? What's the rule? The rule says, can you write it with, is it something x plus, a constant x, or is it x plus y equals a number? 1/4 x is totally okay, right? That's not a problem. If it was 4 over x, would that be a problem? Yes, the x is a denominator. That's no good. But 1/4 x plus 2y equals -4, totally fine. Definitely can be written in standard form because that is standard form, and it is therefore a line, linear. Question, Donovan, or Dizzy.
What about x out of something?
What do you mean? What? If it was this, well, I have a question. So if I have this y over 4 plus 2.847x equals 0, we'll even say, is that conducive to being a line? Is y over 4 conducive to being a line? What's the difference between y over 4 and 1/4 y? What's the difference? What? What's the difference? Look here, what is 1/4 times y? Isn't that 1/4 times y over 1, which is just y over 4? Isn't that the same thing? Right? So what's the difference between y over 4 and 1/4 y? Nothing. So therefore, right, if the variable is a numerator, we're in good shape. Right? We're in good shape. Let's look at this one. What about this? Y equals x minus 4. Is that linear? What do I need to do to figure out if it's linear? What do I need to do to figure out if this is linear? Put it in standard form. Can you put this in standard form? If you can, it's linear. If you can't, then it's not. Can you put this in standard form? How would you do it? How would you do it? Well, what would plus 4 do? Plus 4 plus 4. Now I've shifted y plus 4 equals x. So then you go minus x. Now I have y plus x plus 4 equals 0. Right. So that's my whole point here, is that it's not just y plus x. Watch. What you need to do is you just need to, whenever you're going to try and get it in standard form, you're just trying to get the x and the y by itself on one side and get all the regular old numbers on the other. So then what should I have done here? Minus x, right? I'm trying to get them on the same side. They're gone. I now have negative x plus y equals -4, right? Now do I have x plus y equals 4? Absolutely. Is it okay that there's a negative in front of that x? Yep. Isn't that just -1? Right? That's not a problem. So then is y equals x minus 4 linear? Yes. What are the tricks? I've told you a couple. What are some tricks that tell you whether or not it's linear or not? If the variable is a denominator, no good. What else? If the variable is squared or to the third or to the fourth or to the fifth power, that's no good, right? There are others, but those are the big ones you're looking for right off the bat. You're just looking for that right there. What about this? Is that linear? How do you know? One of them is squared. You can just be done and say, no, it's not linear. Okay, it's not linear. It's that simple, right? We will end up dealing with this. This is actually a very common, that's the difference of squares. We'll deal with this later, but this is not a line. This is a curve. This is definitely a parabola. Anyway, we'll talk about it later. Okay. There's something else. Once you have an equation that you've established is linear, okay? Once you've established that an equation is linear, first of all, tell me this. Let's try this really quick. What if I have this? X equals negative 4. Is that linear? Is that linear? This is an important one. Is that linear? It is. Can that be written in standard form? The answer is yes. It is written in standard form because it's x plus y equals a number. You go, where's the y? Yeah, well, what about this? What about x plus 0y equals negative 4? Right? I mean, the 0y is invisible, but it's there. You can write this in standard form. It's not a problem. Do you all know how to graph x is negative 4? What would we do? Where x is negative 4 right here, right? What is it? It's a line that goes like this. That right there is x is negative 4. Is that a line? No doubt. Right? No matter what y is, it's 0 times y. No matter what y is, x is still going to be what? X is going to be negative 4, right? No matter what y is, x is negative 4. Okay? So what about this? What if I have y equals 3? Is that linear? Can it be written in standard form? It is written in standard form. This is y plus, or this would be 0x plus y equals 3, which is, how do you write y is 3? How do you grab that? Well, there's 3 up here, and you just go, there it is. That's, y is 3. No matter what x is, y is still 3. Anyway, let's do this now. Whenever you have established, are you ready? Whenever you have established that your equation is linear, and you've written it in standard form, there is a very simple way to graph this. There's a very straightforward and simple way to graph this. Okay? So here's the deal. I'm going to draw this for you here. Okay. There's our coordinate plane. Here's the deal. What if I have this? 2x plus 3y equals 12. Okay, here's the deal. Here's how you would graph this. You would graph this by finding the x and y intercept. Now listen. What is this point right here? What point is that? You should all be able to tell me what point that is. What point is that? That is 0, 5, right? That point is 0, 5. Okay? That means that the x, look at this. That means that where's the x? The x is at 0, right? On the x-axis, x is 0. Right? And the y is 5. What is this point right there? What point is that? 3, 0, right? You all can see that, right? That's not too difficult to see. It's 3, 0. That means that where the y is 0, right? You see where on this one the y is 0 because it's around, here's 1, 2, 3, 4, here's negative 1, negative. Y, on this one, y is, on that one, y is right here. Where? What is y again? What is the y? That's 0 there, right? At this point right here, y is 0. right? Y is 0 here. So that point is 3, 0. Now, if I were to graph this baby, right? If I was to graph this line, that's what it would look like. Okay, now here's my whole point. What I'm looking for is this. When I have we've established that it's a line, and we've established that, and it's written in standard form. Here's what you can do. Here's one way to graph this, is to find the y-intercept and find the x-intercept. How will I know where it crosses the y? How will I know where it crosses the y? What is guaranteed to be true about our line at the exact point that it crosses the y? What is true? Lauren?
Number before y, right before y is where it intercepts it.
No. Well, yes, but so to use math terms here, what do we know is true about where this line is going to cross the y-axis? What will be true? If it crossed right here, what would be true? If it crossed right here, what would be true? If it crossed right here, what would be true? All of them have something in common. What will be true about where it crosses the y-axis? It will be on the y-axis, but what will be true about that? What makes that true? What will for sure be true about that?
It'll be a 0 on the x-axis.
X will be 0. Right? Wherever it crosses the y, what is true about x? That it's 0. Do you agree with that? Wherever our line crosses the y, x is
0.
Wherever it crosses the y, x is 0. Right? Because our line, unless our line actually is x equals something or y equals something, if it's x equals something, it's going to go like this. It's never going to cross the y. Agreed? If it's y equals something, it's going to go like this. It's going to be a lot straighter than that. It will look like this, again, straighter than that, but it will never cross the x. Does that make sense? So unless the answer is x equals this or y equals this, what is for sure going to happen is our line is going to cross both the x-axis and it's going to cross the y-axis. At some point, it's going to cross them both. So if we want to know how to graph it, one way would be to figure out when x is 0, whenever x is 0, what's that going to be? When x is 0, what's that going to be? When x is 0, look at it. When x is 0, wherever our line is, our line could be like this, our line could be like this, our line could be like this, our line could be like this. What is going to be true? When x is 0, it's going to be on the y-axis. Agreed? When x is 0, it's going to be on the y-axis. So what can I do here? How can I figure out what's true about that? I can make x be 0. Let's make x be 0. Remember, this guy right here is a line. It's not a single point. This is a line. This guy here is a stinking line. Right? So on our line, let's make x be 0. 2 times 0 plus 3y equals 12. 2 times 0 is 0. So 3y equals 12. Divide by 3. Y equals 4. Right? So when x is 0, y is... Does that make sense? When x is 0, y is 4. We just decided that. Why do we know that when x is 0, y is 4? Because I plugged in x is 0. I made x be 0. Now, how else can I finish graphing this? What is true about wherever it crosses the x, whether it crosses here, or here, or here, or here, or here? What is true about that point? That y will be 0, right? Wherever it crosses the x, y is 0. Okay, so then, let's make y be 0. Let's rewrite it. 2x plus 3 times 0 equals 12. That would be 2x equals 12. Divide by 2. X equals 6. X is 6 when y is 0. 6, 0. There's my 2 points. How many points do you need in order to draw a line? Just 2. I can get my little hefty ruler out, my nice little ruler out, and go... There's my line. I drew my line because I figured out where it crosses the x and where it crosses the y. Those two places are called the x-intercept and the y-intercept, right? It's where our line intercepts. What's intercept mean? To cross. Where the line crosses the x-axis is the x-intercept, and where it crosses the y-axis is the y-intercept. Does that make sense? We'll see. We'll see if it makes sense. You guys are going to try one right now. You need graph paper. I would like for you to graph this equation for me using the intercepts. All right, here we go. So here's how you do it. When we're going to, listen, and this works for anything. This works for it. You can graph any equation by doing this. This will not always be the most efficient way of doing it. In fact, it will almost always not be the best way to solve or graph a linear equation. But this is the first way. This one should get you thinking and understanding the overall, like what is going on here of linear equations and graphing. So pay attention, okay? Pay attention. We need to know how to graph this. How many points do you need to know in order for you to graph any linear equation? You need 2. If it's just a line, you need 2. If it's a parabola or if it's an exponential graph, I mean, you need more than 2. But for a line, you only need 2, right? So, what 2 points is the best 2 points to use? What are they called? The intercepts, right? The x-intercept, the y-intercept. You need the intercepts. If you can get those 2, that's easy. The reason why are I finding them so easy? Because I get to come up here and go, okay, I'm going to make x be 0, and what's that going to find for me? The y-intercept. Not just y, it's going to find me the y-intercept, and then I'm going to make y be 0, which will find me the x-intercept, right? Because when x is 0, that's on the y-intercept. When y is 0, that's on the x-intercept. It's that simple. So let's do it. Let's do this. Let's go, okay, I'm going to make x be 0. Negative 3 times 0 plus 6y equals 12. They're gone. 6y equals 12. I'm not even going to rewrite that. We're just going to go like this. Divide by 6, divide by 6. Y equals 2. So when x is 0, y is 2. That's right here. That's 0, 2. Agreed? Okay. The next one. I've now found the y-intercept. I now need to find the x-intercept. The x-intercept. What's true about the x-intercept? Y is equal to 0. I need to make y be 0. So I'm going to go negative 3 times x plus 6 times 0 equals 12. They're gone. Divide by negative 3. Divide by negative 3. That equals x equals negative 4. Right? So when y is 0, x is negative 4. That is negative 4, 0. I'm going to move that just so I can draw my line better. Negative 4, 0. Where is my line? Right there. Goes on forever. In both directions, but there it is. How many of you got that? Okay, that's really it. Now I'm going to show you a little bit of a shortcut here. If you're watching this at home, you can't really see this, but look, I'm going to make this real simple for you. I'm going to show you how to do this so you can do a lot of this in your head using the intercepts. When I have an equation written in standard form, and we know it's a line, look what I can do. If I'm going to find the y-intercept, I'm going to make what be 0? X. That's going to be 0, which means that no matter what's in front of that, what's this going to equal? Just cover it up, right? I'm just going to go cover this baby up right here and make this be a 0. What is 6y equals 12? Y is 2. I don't need to do a whole lot of work here. Does that make sense? Okay, so 0, 2 is 1 point. And then if I want to find the x-intercept, I need to make y 0. Just cover it up. 3x equals 12. What's x equal? Right? Negative 3x equals is negative 4. There we got it. It's negative 4, 0. Does that make sense? You can literally envision just covering that up. It's gone now because we're making y 0. We're making y be 0. Just cover it up. It's so simple. Make sense? It's really not a difficult concept. I mean, even if I had something really nasty there, you can always find the intercepts just by making it 0, and it's not. Anyway, let me give you. Everybody turn to page 157. Let's see if you can do some of these. Tell me on number. Let's take a tiny little quiz here. I want you to do 1 through. 1 through. Okay, one other thing. Stop. Hold on. We're going to go back. Okay. What were the points again? We decided that the points were, was it 2, 2, 0, and negative 4, 0. Okay, or 0. Okay, this is 0, 2, and this is negative 4, 0. Okay. I want us to do something else here. There's another way, and you've done this before, I know. There's another way for you to graph this without using the intercepts. Almost always, I don't know why you wouldn't use the intercepts, because how many points do you need to draw a line? 2. Do you know why sometimes you're going to want to draw a third or a fourth? To make sure that you're all on the line. Does that make sense? Because if I choose 2 points, no matter what is there any way for me to know for sure that I've gotten it right if I choose 2 points? No way, because no matter where I choose it, I've created a line, right? No matter, even if I mess up, I've created a line no matter what 2 points I've chosen. So it's difficult for you to check yourself if you've only chosen 2 points. So you want to choose a third or a fourth to make sure they're all on the line. Here's what I'm saying. One thing you can do is, when in doubt, what do you do when you're going to graph something? Do you remember? Make a table, right? When in doubt, make a table. X and Y. You should always make, at least once, make X be 0 and make Y be 0 once. Does that make sense? So I'm going to make X be 0 here and Y be 0 here. When X was 0, Y was, what was it? When X was 0, Y was 2. When Y was 0, X was negative 4. Let's choose 2 other numbers here. Let's make X be something else to make sure it's on the line. What would be a really simple one to make X be equal to so that we can just make sure that it's on the line? 1. Make X be 1. I agree. So let's redo this equation with X being 1. Negative 3 times 1 plus 6y equals 12. Come on. There we go. Negative 3 plus 6y equals 12 plus 3 plus 3. That is 6y equals 15 divided by 6 divided by 6. Y equals, what would that be? Y equals, what is it? What is 15 over 6? 2.5. It's 2.5, right? Let's go see if that's on the line. Let's see if that would be true. When X is 1, right? When X is 1, does it look like 2.5? Does it look like that point right there? 1, 2.5 is on the line? Yeah. Based on our graph right here, what point should we choose to make sure? What point looks for sure like it's on the line? Does that point there look for sure like it's on the line? Negative 2, 1. How can we find out if that's true? Plug it in. Let's put negative 2, 1 in there and see if it's true. Let's go here. So negative 3x, that would be, what are we saying? Negative 2, negative 3 times negative 2 plus 6 times 1 equals 12. Do you see what I've done here? I plugged in. I think that this point looks like it's right on the line. That would be negative 2, 1. Do you agree with that? If I want to know if that's actually on the line, go plug it in. Where X is negative 2 and Y is 1. Negative 3 times negative 2. Negative 3 times negative 2. 6 plus 6 equals 12. Is 6 plus 6 12? Yeah, so that means it's on the line. Right? This is nothing that you haven't done in the past. so far. We did this last year. I remember. Any questions about it? What I want you to do then is look at number 1 on page 157. Everybody look at it. Nobody says anything, but get your answer in your head. Is that a linear equation? Is one linear? What are you looking for? What is going to disqualify it from being linear? If there's an exponent of a variable. What about this? What if I have x plus y equals 5 squared? Is that linear? Absolutely. Why? Because the variable is not being exponentiated, right? There's no exponent on the variable. That's fine. That's just x plus y equals 25. That's fine. Looking for that, and you're also looking for the variable to be a denominator. That's bad, right? So then looking at number 1, is that a line? Yeah, I can write that in standard form. You'd subtract y from both sides, and it would be x minus y equals -5, totally, right? What about number 3? Look at number 3. Is that a line? Is that linear? Yeah. No variable is a denominator, and there's no exponent there, and so the difference between 2/3 x and 17x is the same thing, right? And -1/3 y, it's fine. It's all good. They're both lines. What about number, well, you guys should know how to graph number 7. How would you graph number 7? What do you need to do before you do anything? No. What do you need to do? Nope. First thing you do before you're going to try and find the intercepts, what do you need to do? Put it in standard form. You should write that on your paper right now so that you know before you start doing the intercepts, you got to put it in standard form. You need to get in that habit. Put it in standard form. Even though right now you might not have to, I'm telling you right now, you're going to want to. Just be in the habit. If you're going to find the intercepts, put it in standard form first. Then, make x be 0. That's the y-intercept. Make y be 0. That's the x-intercept. Okay? And then, like number 9, it says graph each equation by making a table. I just showed you how to do that. What is making a table? On the left is an x. On the right is y. What should you for sure choose in there at some point? 0. Make x be 0. Find out what y is. Make y be 0. Find out what x is. And then choose another point, right? Choose any other point. Usually you want to make x be 1. It just makes things simple. It's going to make things on your graph. If you make x a billion, are you going to be able to graph that? Not really, not on your paper, right? So you want to choose something that's going to stay on your paper. That's why you choose x to be 1. Once you have all three, the x0, y0, and then x is 1, that's 3 points. That's enough for you to verify that, yes, you've made a line. Make sense? Can you graph number 11? Y equals 3. Can you graph that? Yes. How would it look? Straight line. What? Horizontal, vertical, which what? What's it going to look like? What is y equals 3 going to look like? Show them with your arm. What's it going to look like? It's going to look like this, where y is 3, right? So up above 0, and it's going to look like this. That's what y is 3. Right? What if x was 3? What would it look like? Where at? It would look like this. Where at? Right on the 3, right? Right over there on the 3 for you guys. Right on the 3. That's what x is. X equals something is a vertical line. Y is something is a horizontal line. The rest of this you guys should be able to do. Let me see what your homework is. All right. It's page 157 to 158, 13 to 41 even. Most of these are, you can just look at and do, right? If they tell you to graph it, you got to graph it. If they tell you to make a table, I want to see a table. Do you understand? I'm coming by tomorrow to make sure that you are showing your work the way they want you to. I do not care that you can do this in your head. If you start doing this stuff in your head, I promise you I'll start giving you ones you can't so that you actually have to start making tables for real. So how about you just do what the instructions say and make a table when they say to, graph it when they say to, you just follow the directions so that I don't have to make it hard enough that you can't do it in your head. Does that make sense? You're showing your work here. All right. There you go.